Hey guys, what's the crack? So this one says when to calculate resultant force, okay? So if we do anything else, hopefully just memorize that equation. Your formula sheet to where you see resultant force and the words acceleration and mass. And hopefully you can see that equation that says F equals ma, that the resultant force is the mass times by acceleration. So we know what the force is. The force always measured in newtons, that's the number 30, equals the mass. The mass is always measured in kilograms in physics, so that's 12, times by A. Now I want to figure out what A is by itself. And this is a lovely free marks. So to get A is by itself, go get rid of this multiplied by 12. The opposite of multiplying by 12 is dividing by 12. And what we do to one side, we always have to do to the other. So my calculator, what we're plugging in here is our 30 divided by 12. So 30 divided by 12 gives us the number of 2.5. So acceleration is 2.5. Just make sure to add units. So it's going to be 2.5 meters per second squared. Everyone always forgets those units, so just double check that. It says the same force is applied to a second vehicle of mass 24 kilograms. So it's a bigger vehicle, right? We're putting the same force in a bigger vehicle. So let's explain how this acceleration compares to the first. Okay, if I do any math, you can think about this. If I put the same force on a bicycle versus a bus, right? The bus got a bigger mass. The bus isn't going to move as much as the bicycle. So when you have a bigger mass, you get a smaller acceleration, okay? And we know that because of Newton's second law. Newton's second law is this equation, F equals ma. And what it says is the force is directly proportional to the acceleration, but that the acceleration is inversely proportional to the mass. So what that means is the bigger the mass, the lower the acceleration. So I'll explain how acceleration compares. I'm going to say there is a lower acceleration as the mass is greater. And we know from Newton's second law that acceleration is inversely proportional to the mass. Right? And this is that symbol we use to represent a proportional relationship. So normally seen before, if force is directly proportional to acceleration, if the force doubles, the acceleration doubles. But what we're saying is acceleration is not directly proportional to mass, it's inversely proportional to mass. So like the inverse means 1 over. So that's how we write it. Acceleration is inversely proportional to the mass.